I hope you all remember about the Turing machines, and this is the standard example that you should have in mind of one of these Turing machines that works by marking off the letters, which is the main kind of strategy that we've been talking about. And this is the strategy that generally will work for all of these languages which have sort of exponents of n's or whatever in them. Usually you want to do those by some sort of variation on this basic marking strategy where you mark off the first A, which is to say you change it to an A bar, and then you move yourself to the right until you find the matching B and you mark that one off. And you move yourself back to the left and find the next A, and so on. So we've discussed this example many times. Today I wanted to just get us sort of back up to speed and talk about a few more variations on this type of marking machine. I got one, and then I have a couple for you to try. These can be pretty difficult in my opinion. I mean, it'll take you a few minutes even if you know what you're doing. And to be honest, they're kind of difficult for me to grade also. Like if you write exactly what I think you're going to write, then I can immediately tell that it's right. But if you write something that's slightly different, it might take me like several minutes to figure out what is this kid thinking, and is this actually correct? Because there can be many different ways of drawing the diagram that still lead to a correct answer. Anyway, let's just try. So, variations. We've already done a few variations on this basic setup, but I want to try a couple more. How about this one, just to get us going here? A to the n, b to the m, c to the n plus m. So that means you have some amount of A's followed by some amount of B's followed by an amount of C's where the number of C's is the sum of the amounts of A's and B's. So this would be something like, A to the 4, B to the 3, C to the 7. So 4 A's then 3 B's followed by 7 C's. All right. How can we do this in a similar kind of marking strategy? Is it a question?
Easiest to separate C to the N from C to the M.
This is a good idea. Actually, if I were making a grammar out of that, that's exactly how I would think of this. This, of course, is the same as, you could write it this way. If I were doing this as a context-free grammar, this is how I would think of it. And then you could make this inner part and this outer part separately. Or you could also write it with the C's in the other order. Actually, for the strategy that I'm going to suggest, it's a little, for me at least, I find it a little easier to think of it in this way. And that's because my strategy in terms of like marking off the letters, the idea is I'm going to mark off an A and then match it up with one of the C's and then go back to the next A. And then once I'm through with all the A's, then I start marking off B's and match them to C's. And hopefully everything will be all settled after that happens. All right, so the idea is we match A's and C's, and then we match B's and C's. All right, this is my basic strategy here. And so as far as the shape of the diagram, it's going to be like this one, which is just matching A's and B's. But it's kind of like you go through this loop once, which matches up all the A's and the C's, and then you transition and do a thing like that again. So it'll look like, the basic structure here is, it looks like, I have one thing which does one of these. All right, and this part is when I do A's and C's. And then we transition into another one, which does the B's and the C's, right? And then there's some kind of ending at the end, all right? But this is my basic plan, all right? And while we're doing that first loop, A's and C's, we're going to be marking the A's and marking some of the C's, but leaving the B's like they are. Don't mark the B's in that first loop. But then when we come down to the next loop, that's when we start off marking the B's and marking the C's also. All right, so let's see if we can make this happen. I'm going to scroll away from all that just so that I can fit the picture. But The first part of my diagram is going to look like that basic machine that I had written before. So I'm going to go AA bar R. That means mark off a A and then move to the right. I'll just refresh my memory. What I'm talking about has this format. All right, so you mark off A, and now this the next state, I'm going to put a looped arrow, and this one needs to move myself to the right through some other stuff. One thing is I have to go through some other unmarked A's, right? Anything else I need to move through? Remember, my goal is to hit the first unmarked C. Yeah? You may have to go through marked C's. I agree. That would be, if I had already marked off some of the C's in later steps, I will have to go past the ones that I already marked. Anything else? I think there's also,
B's.
Yeah, the B's, right? In this step, I am also going through the B's, which I'm like, for the sake of this upper triangle, I'm just going to leave the B's the same the whole time. Okay? Eventually, moving to the right here, we will make it to an unmarked C, which I then mark, and I guess I can start going to the left again at that point after having marked the first unmarked C. And now I put another looped edge here. Now I want to move myself all the way back to the beginning. That is, I should move back through other marked C's, C bar, C bars, other B's, and other unmarked A's. I'm looking for a marked A bar, R, and that is my signal that I sort of went back far enough, move one more step to the right, and we should be looking at a unmarked A. All right, so this is my first loop. Everybody feeling good about that? I hope I haven't messed it up yet. I think that this is what we want. All right, now I'm going to transition into the second loop. So I'll have sort of an outgoing arrow here. What's the trigger that how do we know that we're done in this step? Anybody have a, like in this one over here, I had this B bar, R. That's because after you mark all of these A's, the signal that you actually made up, marked off all of these A's, is that the next thing you see is the first marked B. Can anybody say here, how do you know that we're actually done? What do you think? Yeah, when we see an unmarked B in this step. So I'm going to put B. Now the next loop, I didn't finish drawing the end of this arrow for a reason, because something slightly perhaps unexpected will happen about how I'm going to draw this arrow. But the next loop involves marking the B's and the C's. So actually, since I'm looking at the first unmarked B, I might as well start marking the B's right away here. So I'm going to say B bar, R. And then I'm going to go into this loop down here. The slightly weird thing is this arrow is actually going to point there, and we can talk in a moment about why that is. But what this loop looks like is you start by marking a B. At this time, I'm matching up B's and C's, right? So you start by marking a B, and then over here you move to the right. Now, when I'm doing this second loop, actually, I should never see A's or marked A's at all. All the A's should be sort of further to the left. So I don't have to worry about A's here. I think we can just say you're going to move to the right through other unmarked B's and perhaps some marked C's, definitely some marked C's. And then once we see an unmarked C, I mark it and go back to the left. Going back to the left through unmarked C's. Maybe not unmarked C's. Maybe just marked C's. I think just marked C's, although it wouldn't be wrong if you put unmarked C there. And also through some unmarked B's. Maybe that's what I was thinking of. And then finally, if you see a marked B, I move one spot to the right, and we're back ready to mark the next B. So this again is that standard sort of triangular loop that we've used many times before. All right. Why does this arrow go to here? It's because when we're leaving this state, I said we might as well just mark the first B. And that means after doing this step, we actually are sort of beginning this loop in kind of step 2 of the iteration because we already marked off the first B. So it's as if we had just done that first step sort of automatically behind the scenes. All right? This is complicated, but we're basically done here, although we need to have sort of a thing that happens at the end. And again, we should think about, remember the basic format that I'm talking about? I scrolled it, but it's this, right? Going through this loop involves marking these B's. Eventually, we will have marked off all of the B's, and we'll be in this state looking at a marked C, and that's the trigger that we're finished. So I'm going to say something like this. C bar, R, looking at a marked C, and then you, just the little end thing here is we want to run all the way to the right through the rest of the string and make sure the only thing we see should be marked C's. There should be no extra business on the end of the string. So I'm going to go C bar, R. And if we get all the way to the end, we'll see a blank, and then it should be accepted. So this is my full thing here. It is basically just two of these three-way or three-state loops, sort of plugged one after the other. All right. These can be tricky, in my opinion. Any questions about that? Thoughts about that? Yeah. Oh, yeah, sorry. This just does it once and then once again. Yeah, this is not what I meant. I meant that should be a loop and then this B bar, this blank blank R, sorry. Thank you for this. I mean that. And that C bar thing should be a loop. Yeah, I don't know what I was thinking. Right, as I wrote it, you just do it exactly 2 times and then stop, but that, of course, is not what I meant. You need to go through all the remaining C bars, no matter how many there are. All right, excellent. Thank you for that. Any other complaints from the peanut gallery? That's what my wife likes to say to our kids. One time, one of my kids, he was like 5 years old maybe, he said, "I'm proud to be a member of the peanut gallery." And then recently I learned Professor Sean Rafalski informed me that the phrase peanut gallery is kind of racist. I never knew this. This is one of those things that you find out sometimes. I guess this is it was a reference to like segregated theaters where the black folk had to sit in the back and they had peanuts. I don't know what the connection was, but apparently it was a derogatory statement about those folks, those rowdy folks sitting in the back. So don't say peanut gallery. All right. Any other thoughts about this? When I was yeah?
Does this allow m to be 0?
Oh, you're talking about this? Yeah. So
No peanut
talk about.
gallery.
Don't talk about the peanut gallery. This is a good question, and my immediate answer is I'm not really sure. But yeah, it's a good thing to think about. Are we sure that this will actually work when this or that of the variables are zeros? I think probably it does not allow m to be 0 because the only way to get here is by going through this arrow, and this arrow requires that you see a b. Do you have an idea of how we could remedy that?
You could skip from the start state to the second to last state.
Yeah, I think if there were a special arrow here, so in the case where there really are no B's, it means you'll encounter a C bar at this point instead of a B. And if you can, I would put an arrow, I think what he's saying is like this. So this is great. An arrow like this. Sorry, it's hard to tell where my labels are going. Something like that. I think that would do it. And if you want to get really technical, do you have an extremely technical question as a follow-up? There's actually one other special case.
Doesn't take the empty string.
Yeah, what if the n and the m are both zeros? That is, there's no nothing here and we have an empty string. That also should be a special case technically. And I would, if I really wanted to be super careful about that, I would just do something like this. That means if we have a blank at the very beginning, it should be accepted.
Couldn't you just like add on for that other special case just the blank one?
Here?
Yeah.
Blank, blank, R. Yeah, I think that would work also. Yeah, so if, I think that would work also. Yeah. He's saying in this C bar R, you additionally put blank, blank, R. So if you start with a blank, you would go down here. It would not be accepted immediately, but you would see another blank, and then you would go over here and be accepted. So yeah, I think that would work also. Yep. Great. These are good questions to ask. I would say in general, because this drawing these Turing machine diagrams is so complicated in the first place, on our homeworks or tests or something, I am liable to not necessarily expect that you are thinking about these kinds of technicalities. Although I hope, I don't intend for the questions to be ambiguous or whatever, but if you, this amount of detail is not something that I would necessarily, like if I asked you to do this question on a test and you forgot about this arrow, that would be okay with me. But of course, if you want to double check, that's a good idea. All right, I have some for you all to try. Now, this next one actually is not a similar kind of two loops in series. It's more like one big loop, which is slightly more complicated than the ones we've done in the past. I would like for you all to try, let's try A to the n, B to the n, C to the n. This is the fabled example of a non-context-free language. All the ones that we've looked at so far with these Turing machines have been context-free, but this one is not. A to the n, B to the n, C to the n. But I hope that you can see what's the strategy going to be here. If I were to say the strategy in words, it would be mark off one A, then move to the right, mark off a B, but then instead of going back to the A, just like keep going and then mark off a C, and then go all the way back to the A's at the beginning and do this again. Basically, it should be a loop where instead of, when I did it, instead of 3 steps, I had 4 steps in my loop, right? You mark the A once, then you mark the B, then you mark the C, then you go back to the beginning. See what you think. And let's say I don't care about if the n is 0. So let's assume the n is not going to be 0, just so that we don't have to worry about that. Yeah, what you need here is only applicable in later iterations. Any comment about, I don't think any of this is wrong, but I think you don't need these C's. You probably don't want them, because at this point, actually, it should not be C's. Because we have People seem to be doing great. I'm going to draw my answer here. All right, this is what I have for the main loop here. And as I was going around, it looked like people did great here. So you mark a A, and then I move to the right through other A's and perhaps marked B's, and then mark a B, and then keep going here. Some people also put something like CCR in this position, which I think is not wrong, but also not necessary, because you actually, at this point, we're moving like in this part of the string between the A's and the B's. You should not be seeing any C's at this point. And so if you encountered a C at this point, then your machine ought to just stop and reject the string. So I would say don't write a CCR or a C bar R. Anyway, here we're moving between the B's and the C's, which is why I didn't put A's here, because actually there should not be A's in this portion of the string. Mark off C and then go back to the left. And then we have to go all the way back through all of these other things, so that would include both types of B's and the marked C's. When you see an unmarked, and the unmarked A's, when you see a marked A, that means you made it back to the beginning. As I was walking around, pretty much everybody wrote something that was at least very much like that. I hope everybody feels good about that. And then the ending. So the ending, as far as this loop, would be after we get to... this loop will end when we've marked off the last A. So we will be ending sort of like in this position. The last A having been marked, we'll be looking at a B bar if all is good so far. So sort of the my kind of trigger to start the end is this, B bar. And then we need to go through the rest of the string, making sure that the only things left in the string are B bars and then C bars. And you could, I'm going to do this in a very sort of kind of OCD sort of way. I want to see a bunch of B bars first, and then a bunch of C bars. And then a blank, which is the end. All right, so I broke this apart into two states here, making sure that first I see B bars followed by C bars. And as I was walking around, I saw a lot of people, instead of that part, they just kind of did this both at once. This is, I think this is still correct. My version, I would say, is more strict about making sure that there are B bars and then C bars, rather than some kind of mixture, or I'm trying to avoid a situation where they come in a weird order, which this, in theory, this could still accept the string even if they're in a weird order. Although, if you wrote the first part, like the big loop, if you wrote the big loop correctly, then it would never even have made it through the big loop if they were in a messed up order. So probably either of these eventualities will be okay. Although if like I said before, if you put like C's in this loop and A's in this loop, then probably it would still be accepted even if they were in a weird order. So you can decide for yourself how particular you want to be about that. All right, any questions about that? A to then, B to then, C to then is not context free. And I would say the moral of this story is Turing machine really doesn't care if it's context free or not. I mean, this is not context free, but it doesn't, because of that, like it doesn't require any kind of special tricks to make a Turing machine to do it. I mean, you just do it kind of like all the other examples that we've been talking about. All right, excellent. Thank you for that one. I have one more, and then I had one more for you all to try, although I don't know if we have enough time to do both of that. but let's talk about, so I do want to talk about sort of a significant variation on these methods. I would like to do I'll put it down here. How about a Turing machine for x in AB star such that x equals the reverse of x. All right. This one also we can do by marking letters, although there's one kind of special trick that is necessary in this example, which we haven't had to do in our previous examples. But, you know, I'm talking about strings which are sort of like A, B, A, B, A, something like that. This is an example of a string for which the string is the same as its own reverse. And how am I going to do this? By marking. I am going to do sort of, I mark off this A and then run down to the end and mark off that A and then run back to the beginning, mark off the B and then go down to the end, mark off the B, right? It's very similar, although I have to go all the way to the end to find the match, and then all the way back to the beginning, I guess, and somehow find the first unmarked thing. All right? This is a little different from our A to the N, B to the N example. We never went all the way to the end. We just went until we saw the first B or whatever. But what makes this harder than the others? There is a special kind of trick that you have to do in this case. What makes it interesting is I have to, for instance, mark the first A, then go to the end and mark the last A. All right? The thing is, after you mark an A at the beginning, you have to go to the end and you have to mark an A at the end. But if I had marked a B at the beginning, I would have to go to the end and mark a B at the end. That means while you're going sort of through the middle steps, you have to kind of be remembering what you saw at the very beginning, if you understand what I'm saying. You have to sort of say, I marked an A at the beginning, and then I go bop, 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 the head moves across. And then when we get to the end, you have to still know at that point when you're at the end, should I be looking for an A or a B at this point, all right? It means that our main sort of marking loop, actually, we need sort of two parallel tracks through this loop. One in which you are going to the end in order to find an A, which matches an A at the beginning, and a separate parallel track in which you're going to the end in order to find a B, which matches a B at the beginning. So here's my idea here. So, I mean, as we move to the right, this is the problem, or this is what's different about this example from previous ones. As we move to the right, we must, I will sort of put this in quotes, remember which letter we're looking for. All right, this is different from our other examples, like in A to the N, B to the N. You always see A first, and then you mark it with a B. And then you go back, you mark A at the beginning and B at the end. It was always the same every time, but this is different. It could be A's at the beginning and an A at the end, or it could be a B at the beginning and a B at the end. So as we move to the right, we must remember which letter we're looking for. And the way we do this is I'm going to use, I'll call this sort of parallel branching paths. All right. And so here's the sort of large-scale structure of this machine. It's going to be like this. I have two ways through the machine. There's that way across the top and this way across the bottom. And basically, across the top means, this way means that the first letter was a A. This way means the first letter was a B. And then this makes a loop, and I'm gonna, it's convenient the way I'm drawing this. I'm gonna sort of make a loop that way. So either way through, you're gonna end up going back to the beginning. But you have to do something slightly different if the first thing you saw was an A versus if the first thing you saw was a B. So this is the basic structure of the loop I'm doing. I'm really, this is two sort of loops of 4 states. But each time through, you could either go across the top or you could go across the bottom, depending on which of those letters you saw first. All right, let me try and draw this in a nicer way. So I'm going to make a new version of this picture here. Okay, let's draw the A version first. The B version will be very similar and actually in many cases exactly the same. It's just you have to draw them slightly different. I'm going to leave a little space on the top just because I'm going to have a lot of labels on various things. But anyway, the A version of this loop starts like that, right? This is if we read A at the very beginning. You mark the A at the very beginning, and now I need a loop which moves me to the right over and over again. Anybody want to suggest how should we move to the right? We want to move through a bunch of A's and B's, yeah?
Through A's, B's, and B bars.
Through A's and B's and B bars. I wasn't going to say B bars. If you think about, I'm going to try and draw, let's say, here's an example string. What does this look like if you're kind of like in the middle of doing this procedure? Let's say I had marked off the first 3 and then the last 3, and then I'm starting at, I would be looking at this A here. You want to move to the right. I think we don't necessarily have to go all the way to the end. I would say we move to the right until I see something that's marked and then back it up by 1 position because the marked ones are at the end. Or maybe I'll go all the way to the end and see a blank and then back it up by 1 position. I don't think, even if I'm looking for A, I don't really want to move through marked B's. That's a sign that something has gone wrong, I think. So yeah, I'm going to do that. And then how do we know when we sort of made it too far? That's if you see a marked thing, you should back up by 1. So I'm going to say an arrow here. And if I see a B bar, I back it up by 1. And then I should be pointed at the first or the last unmarked letter. All right. Of course, I could also at this point see an A bar and back it up by 1, right? You go until you see the first barred thing. Or perhaps, at least the first time through, you might actually go all the way and see a blank. So I'm going to put a blank on there also. Blank, blank, L, like that. Right? I think, so once I do that movement to the left, we will be in this state, we are pointing at the last unmarked letter. And because I'm on this branch, the last unmarked letter better be an A. And at that point, it should get marked. So I'm going to go A bar. And now I suppose I can put an L here because now we, after marking the matching letter, we're going to move back to the left. All right. And now I want to go all the way back to the left. Basically, it's a similar thing. When I'm going back to the left, I want to go until I see something which is marked, which means I overshot it. Sorry, you can't see my helpful dot here. Going back to the left, I go until I see something marked, which means I overshot it, and then I have to move 1 space back to the right, and I'll be back at the beginning of my loop. So I have loops like this going to the left through unmarked A's and unmarked B's. But when I see something marked, I'm going to go back to the starting state. Marked B, unmarked A. And that's one trip through the A version of this loop. All right. That's if the first letter is a A. I'm going to put a separate sort of parallel thing, which is kind of the same, only interchanging the roles of A's and B's across the bottom. So that should look like so. And this starts with B bar R. My looped edge on the first state there shall be, I think actually this one can be exactly the same, right? In fact, the movement as you're moving to the right should be the same in either case. It's the only difference is really marking the A and the A at the end. It's going to be exactly the same, only we start by marking a B and mark a B at the end. So here I'm again going to say AAR, BBR, exactly like before. Here, A bar, R. This is all about just moving myself to the end, which should be exactly the same in either branch. And then finally over here, B bar, L. And now I think that's it for the whole thing. I forgot the blank. Yes. Yeah, we need blank, blank, L. How come those say L's, but I wrote R's? It should be L's. Sorry. I was trying to copy the same thing. L's. I'm taking a L. All right. Excellent. So this whole thing will have marked off everything. Again, we need to think about the ending. Somehow there's some indication that we made it to the end of something or other. Any ideas about what will actually happen at the end here? The end will look something like, in a simpler example, how about A, B, B, A? This is a very simple example. We mark that A, then we go back. Mark this B, then we go back. I suppose in the going back part, let's say I just marked this B. I would do this once, and I would be in this position. I think we would end up with the head right there, pointing at this B bar. So it seems to me the trigger, how you know that you're done, is in the starting state, you are looking at a B bar or an A bar. If in this starting state you're looking at a marked off letter, that means that you have already matched up all the things on the right and the left. So that's what my little ending spur is going to say. Now, I don't know if this marked off letter will be an A or a B, so I just put them both. A bar, R, B bar, R. And then, as usual, I want to check to make sure that there's no extra stuff left on the end, which never got matched with anything.
Should you also have a blank there for empty string?
Blank there. Okay, if the entire thing is the empty string? Yes. I think this is, if the entire thing is the empty string, yes, I agree. Blank, blank, R. Yes, that's a technicality, but yes, good catch. And then from here, we need to, as we have in other examples, run all the way to the end of the string, moving to the right, checking to make sure that everything has been marked. So this should look like A bar, R, B bar, R. Finally ending up at a blank when you get to the very end, which should be accepted. Yes, and if the entire string from the very beginning was the empty string, then we'll go down this blank arrow, and then it will again be blank, and so it'll be accepted. Yeah, great. There is actually one more technicality to discuss, but any questions about this so far? I hope that everybody is feeling okay about this. Anybody feel like there's another technicality? Yeah? Yeah, you may have noticed all the little examples that I've been drawing here have been even length. If there's odd, what's the difference if it's odd length?
There's one character in the middle that doesn't get marked.
Right, if it's actually odd length, you will have one letter left over in the middle which never gets marked with anything, and that's okay, right? As is, that kind of a string will be rejected by this machine because it doesn't allow for this one extra letter left over in the middle. So we have to think about what would happen to this machine and how could we try to deal with that. So I'm thinking about what about something like A, B, A, B, A, right? This one would have, I mark this A and then that A, then this B, then this B. I want to make it so that that is still accepted. Any ideas? Can we make that happen? in the machine as is, I think if you tried one of these strings, it would just get stuck at some point. Maybe it would be helpful to identify exactly where would that get stuck and then see if we can deal with that somehow. Any thoughts about that? Like, okay, this example, for instance, I would mark this first, then that, then the B, then the B. Then I would go back. Now, if I didn't know any better, and like the machine doesn't know any better, it would start the next time through the loop by marking this A, right? So right here, it would still do that. Next, it sees a B bar. So it would still mark this A in the middle. Then it sees a marked thing next, and so it would do this B bar L, move back here, and in this state, it would be looking again at that A in the middle that was marked, A bar, right? I think actually that's the only way that that could happen. If I just put A bar, this direction doesn't matter, accepted right there. That special accepting state is just to handle this case where there was one extra A bar in the middle, or one extra A in the middle. The only way that this could ever happen, that you could see an A bar right here, is in exactly this situation. All right, maybe, now that I say this, you still need to do this check at the end. So maybe I would put, sorry to cross the streams here. This arrow probably should go like this. I want to draw the arrow from here to there. This is going to look ugly, but because you still, at this point, if you check off the one in the middle, you still need to make sure there's not extra stuff all the way at the end. Is that really true, what I'm saying? I think it was okay before. Sorry. I don't think it's possible there could be extra stuff at the end because because of the way the rest of this works. Yeah, I'm going to say, let's just put it like that. You can tell I'm less sure of myself at this point. Yeah, I don't believe it's possible that there could be extra stuff at the end. In order to get here in the first place, you will have already seen a blank on the end, which means you actually did run through the whole string at least once. Okay, anyway, one last thing. So that is the special case in which there was an A in the middle. There's also a special case in which there was a single B in the middle. That has to go right here in a similar little guy here. B bar R. That handles the similar, like, symmetric case in which there was an extra B sitting in the middle of the string. All right. A lot of ins, a lot of outs. It's complicated. I had one more example like this for you all to try, but I think it may have to wait until next time. You may have noticed I got a pocket full of markers here. I wanted to have you guys all sort of stand up and draw some things. Maybe we'll do that next time. I hope that sounds exciting. If not, stay home next time. I don't know. It sounds exciting to me. All right, we'll try a couple more examples next time, and then we will actually go on to another thing. So, we have several weeks left of this class. They are not all going to be, let's just do increasingly more complicated examples of these. At a certain point, we're going to move on to something else. Let me know if you got homework questions or if you want to go over the test. I would be happy to talk about it.